So today's class we are going to see about memory architecture. So in memory architecture already we have seen various parts of CPU. So in CPU we are having memory unit, ALU and control unit. In previous unit we have seen how the arithmetic and logic unit is working, how the instruction sets they are being executed and all. So in today's class we are going to see about memory architecture. In CPU, whatever the memory unit we are having, that is a register set, various set of registers we are having to hold data intermediately, and for immediate operation whatever the data we are using, that it is stored in the registers. But in registers, instruction by instruction, one instruction, the address of the instruction, program counter we are using, address register we are using instruction register. So various registers we are using for temporary storage, that is all. The complete program should be available for CPU for execution purpose. So here in the memory architecture, the hierarchy of memory, so first we are going to see about the hierarchy of memory. In memory mainly we are having three types of memories. First one is main memory, which is also known as primary memory, then auxiliary memory, which is also known as secondary memory, and cache memory. So here from the starting class we are discussing about this thing that CPU can directly interact with only main memory. So when you want to execute a program, the set of instructions, that means the program and all the related data, everything, it should be available in main memory. Then only processor can take that content into the processor for execution. Suppose the program is in the secondary memory, directly CPU can never interact with secondary memory. Then what it has to do, if the particular thing which is necessary for the execution, if it is not available in main memory, then IO processor, it will be activated to search from the secondary memory and transfer to the main memory, then only it can be executed. So here the main memory is it plays very important role in the execution of the process or program, and nowadays we are having multi-programming systems. So more than one program can also be stored in the main memory. Here suppose one program while it is being executed and it requires some IO, but that IO is not available in memory. So it will transfer the instruction, it will give the instruction to the IO processor to transfer, to load that particular information which is required for continuing the execution, and meanwhile CPU will not be idle, processor will be allocated to some other program or process which is in the queue, next which is to be executed. So one thing which we have to mainly remember is CPU can interact only with main memory. It can also interact with cache memory, but cache memory it is very less in size and it cannot hold much data or much information. So main thing which is necessary is CPU can interact with only main memory. So all the things whatever that are necessary to execute a program, that should be loaded into the main memory. Now coming to cache memory it is less in size, smaller in size compared to main memory, faster compared to main memory. Then what is the necessary of that? Necessary of cache memory is to increase the speed. Why to increase the speed? Processor, it is a high speed, and comparatively from memory, if it is required to search and take the information, it will take much time. There are certain informations, there are certain things which are repeatedly used. So in such cases what we will do is, we will transfer that information and we will keep it in the cache memory. So at each and every level what we will do, CPU processor will search for the information in the cache memory. If it is already existing there, then it is easy for the processor to get that information and continue with the process. So if it is not available in the cache memory, then it will go for the main memory. So it is just like, suppose your books, if you are taking in the shelf, if you are placing the books, so the books, reference books, only once for a while, whatever you are reading, that all that will be placed in the shelf. But a general notes, running notes, whatever you are using daily, or a book which is daily used, that will be placed on the table, such that easily we can access that, need not to search each and every time whenever we want to search. So as I told you, comparatively the size of the cache memory is small, so it will be very easy for us to search in the cache memory, and repeatedly whatever the information that is required to execute the process, that will be stored in the cache memory. So their hit rate, we are having hit in the sense whatever that thing information we are searching for, if you find that in the cache memory, then it is hit, otherwise it is miss. So this ratio we are maintaining such that in a fast mode we can complete the execution. We are having the hierarchies, previous. So this is about main memory and cache memory. Another one we are having is the secondary memory, auxiliary memory. So here main difference between primary memory and secondary memory is, first one is main memory, it is directly interacting, processor can directly interact with the main memory. So whatever the things that are necessary to complete the execution of the process, that should be placed in the main memory. Whereas secondary memory, it is permanently stored. So here main memory, whatever we are storing, that is volatile. That means once if you switch off the system or the power is off, automatically whatever you are storing in the main memory, it is gone. Nowhere it is available again. Whereas a program, suppose a C program you are storing, so .c you are saving. Saving means you are storing in the secondary memory. So once if you are storing in the secondary memory, it is permanently stored. It is non-volatile. It will not go. So once if you are switching off the system also, again when you are switching on the system, everything whatever you are storing in the secondary memory, it is available. And it is large in size. But it is slow because processor cannot interact with the secondary memory. So from secondary memory, if anything is required, first it is to be loaded into the main memory, and from main memory then processor is going to access it. So coming to the hierarchy, here we can represent the hierarchy of the various memories, whatever we are having. First comes register memory. So the register set which we are using in the processor, already they are there. So already we have used various registers such as accumulator. So they are having very fast execution or reach to the processor. Next comes cache memory. So after registers, the first register which is very close to the processor is cache memory. Then comes main memory, which is also known as primary memory. So though processor, it can interact with only main memory, in between main memory and processor we are having the cache memory also. And then comes auxiliary memory or secondary memory. So here by this diagram, by this picture, we can clearly understand that the size of the memory, if you are taking, it is downward increasing size. So registers, very small size, 8-bit registers, 4-bit registers, 8-bit registers if you are having, only 8 bits at a time we can hold there. Cache memory, if you are having in KBs maximum, you can hold the data. Whereas in main memory, in GB you will have how much data you can hold at a time. Whereas secondary memory, if you are taking in terabytes you can hold, it is very large in size. When coming to speed, it is in the upper way, it is high increasing mode. That means if you are having something in register memory or cache memory, in a high speed it is reachable to the processor. Whereas if you are having something in the secondary memory, then it is slow because once it has to be transferred to the main memory, and then only the main memory processor can reach, or a processor can access through that main memory. So a long process is there, that is why a bit slow it will be. So basing on size, if you are taking, it is in the from top to bottom, it is in the increasing size. Basing on speed, if you are taking from bottom to up, it is in the increasing. Whereas cost, if you are taking this one, it is low cost, and cache memory, it is too costly. So, and in upward arrow only, in the upward direction, it is in the increasing way, the cost if you are comparing. Now coming to characteristics of main memory. So already I told you, CPU can directly interact with only the main memory. So whatever the information you want that is required to complete the execution of the process, everything it is to be loaded into the main memory, first point. Next, coming to the characteristics, these are the important characteristics. First you can see it is very closely connected to CPU. Then contents are quickly changed because it is directly interactive with CPU or processor. So whatever the changes you want to make, whatever the content that is available on the main memory, it can be easily changed, very quickly it can be changed. Then that processor, whatever the program or process it is working on, all the relative information it should be held by the main memory. Then only it can work. Directly from the secondary memory it cannot take. And basing on the speed of the process, so now here in 1 second if you are comparing also, some million of times the processor will be interacting with the main memory, and whatever you are storing in the main memory, nothing is permanent. So once if you are switching off the system, everything whatever you are storing on the main memory, it is gone. That is why we will call it as volatile memory. So here mainly main memory, it is divided into two parts, RAM and ROM. So RAM, it is random access memory, which is also known as read and write memory, and ROM, it is read only memory. Now as we are saying, main memory is volatile, but still some portion of main memory we are having ROM, read only memory, which is non-volatile. That means in ROM, whatever we are storing, it is permanent, it will not be deleted. Then what is the purpose of that? Why we are saving that? Why we are saving that is, first point is, I told you that processor can interact only with main memory. Now second thing is, once you are switching on the system, you can observe that something is happening within the system, which is nothing but the system, it is set ready for the use of the user. That means it is adjusting everything, input, output, whatever the things that are necessary, operating system, it is set into the main memory and all this, which is nothing but bootstrap loader programs. Automatically they will be executed. So for that reason, in main memory we are having a part read only memory, but here we cannot write anything, only we can read from that read only memory, which is non-volatile memory, mainly the programs which are mandatory to run, such as bootstrap loader programs that are available in the ROM. But various types of ROMs also we are having, programmable ROM we are having, erasable programmable read only memory we are having. Basing on the importance and basing on the situation, we will use that, and most probably we will use only ROM, where the bootstrap loader programs are loaded, and that is used to start the system and make it comfortably available for the user to use. Coming to RAM, which is known as random access memory, which is also known as read and write memory. So here this is the main memory which we are using in the system. So configuration, when you go to purchase a system, so laptop or anything, they will ask the configuration. So you will say, I want this much RAM. RAM means this is the thing where you are mainly using for writing purpose and reading, both the purposes you can use this. So here in RAM you are having two types. One is SRAM, which stands for static RAM, and second one is DRAM, which stands for dynamic RAM. So here the difference between static RAM and dynamic RAM is, static RAM, it is nothing but collection of flip-flops. We know the flip-flops already, previously also we have discussed about this. A flip-flop means it can be stored, one bit can be stored in that. So a connection of that, a collection means some set of flip-flops, they are set together to form the SRAM. And this SRAM, it is mainly used to design the cache memory, and it is costly. So it is a bit expensive and also faster. That is the main difference, characteristics of static RAM. Coming to dynamic RAM it uses capacitors and it reduces the power consumption. So less power consumption and large data it can be used. That is the reason it is used for the design of main memory, because comparatively the size, if you are taking cache memory, it is small in size, and main memory it is large in size. So by using flip-flops, if you start designing main memory, it is very difficult for us. That is why here we are using capacitors which can reduce the power consumption and large data can be stored. We use dynamic RAM for the designing of main memory and static RAM for the designing of cache memory. Now coming to RAM design. So RAM, it is constructed by using the integrated circuits. So now here, what is the structure and how it is working? Separately we will see for RAM and ROM also. Then we will go for how CPU is connected with the memory and how it is working. So before that, let us say here in RAM chip we are having control inputs, and what are the various control inputs we are having? Two select lines we are having, CS1 and CS2. One read and write commands are having. So when we want to read command is activated, it is 1. When we want to write command is activated and it is set to 1. If it is 0, we are not, that particular command is not activated. And address bit we are having 7-bit address. So 7 bits we are using to send the address. So here either we are reading or writing. So what is the address? That to maintain the address we are having this address AD7, which consists of 7 bits. And data bus, it is connected 8-bit data bus. So why 8-bit data bus? Here in this RAM we are using 128 by 8. That means 8-bit, the word length 128 words we can consider to store at a time. So this is for one RAM. Like this way, multiple RAMs can be stored within the system. How many RAMs we are storing? That it depends on how many selection lines we are using. So more number of RAMs if we are using, more number of selection lines we have to use. So here, what are various combinations? Let us see. Suppose selection lines both are 0. Here X represents don't care condition. Don't care condition means it may be 0 or 1, whatever it may be. But here if it is 0, that means both the selection lines are 0, we are not selecting anything. So inhibit high impedance, that means nothing is done. We are not doing anything. So here the main operations what we are doing is reading and writing. Only 2 operations we are having, read and write. So when we are having that read and write, when it is 0, 0, we are doing nothing. When it is 0, 1 also, whatever may be the conditions of read and write, it is wherever we are having inhibit and high impedance, that means that we are not doing anything. It is idle. So here if it is 0, 0, 0, 1, we are not doing anything. If it is 1, 0, the main portion it works on 1, 0. So if it is 1, 0, it will work, but when it is working, that particular operation it has to be set. So in this third case, if you are taking it is 1, 0, so it should work, but both read and write operations both are 0. So both are 0 means nothing we are doing. So that is the reason again we are having inhibit and high impedance. So nothing is done again. So next case 1, 0, 1, 0 means it is active, and here write bit is set. When write bit is set, we are going to write. Write means where we are writing? We are writing in the memory. Memory means here RAM. ROM we cannot write, it is read only memory. So only in RAM we will write. That is the reason write means input data to RAM. So in the RAM, we are sending through CPU, we are sending the data which is to be written on the RAM. 1 0 and read bit 1 if you are taking, read operation is active. Read operation active in the sense output data from RAM. From where we are reading? We are reading from memory. Memory means again here RAM is active, so from RAM we are reading. So from RAM to outer environment if you want to do, then we are having 1 0 and 1. If we want to write to the RAM, we are having 1 0 and for write operation 1 set. Whatever operation it is set, that particular operation it is going to be performed. So here write means we are writing on to the RAM and read means we are reading from RAM. We are bringing out from RAM. And 1 1 also it is inhibit. So it is no active operation, it is performed. Now coming to ROM chip, previously whatever we have seen, that is the RAM chip. Now coming to ROM chip, read only memory chip, here also we are having 2 selection lines, and here the address line is 9. So here what we are having, it is required for us to maintain 9 bits to set the address, whereas RAM it is sufficient if you are having 7 bits to set the address. And here also we are having data bus, but here one thing we can observe, that from the data bus towards from the ROM towards the data bus only we will have arrow, because it is read only. We cannot send the data from outside environment to ROM, only we can read. So only one side arrow and only. So here ROM if you are taking, the size of ROM is 512. That is the reason that address bus also we are having 9 bits to hold the address. Now this is the memory connection to CPU. That means how the memory is connected to CPU and how it is working. So now here we are using 4 RAMs, 1, 2, 3, 4. So these 4 RAMs, first thing we have to select which RAM, and also one ROM is there. So here various bits we are having, depending on what bits we are using, we will discuss about each and entry, how it is going to be performed. First we are having data bus. So database is connected to all RAMs as well as ROM. So here basing on some decision we are selecting one of the RAMs. So if we are selecting the RAM, both way it is connected to data bus, because either we can write or we can read. That means both ways, the data should be sent from RAM to bus also, from bus to RAM also. That is the reason that for the RAMs, 2-way connector it is there. That means both the sides you can send the data and receive the data also. Whereas for ROM if you are taking, it is only read only memory. Read only memory is only you can send the data, you cannot receive the data. That is why only one side it is connected. That is first point. Second point, there are 4 RAMs and only 1 ROM. So there should be some decision making which one you are selecting. So before going that, we are having address, read and write. So previously we have already seen there are 2 operations for RAM, read and write, basing on the bit. If the bit is set to 1, then it is that operation it is performed. And various combinations also, how when the read operation is performed, when the write operation is performed, is clearly explained in the previous slide. Now this read and write, these bits it will decide whether you are going to read, whether you are going to perform read operation or you are going to perform write operation. First these 2 bits. Then coming to 1 to 7, that means bits 1 to 7. That bits they are used for specifying the address. So 1 to 7 bits if you are taking, these are connected to all the RAMs and ROM. So all the RAMs, RAM 1 is also connected, RAM 2 is also connected, 3 is also connected, 4 is also connected, as well ROM is also connected. So address it is connected. But here one thing you can observe, all these RAMs we are having AD7, 7 bits are sufficient to maintain the address. Whereas here we are having AD9, 2 more bits are required. That 2 more bits we are having in 8 and 9. So suppose ROM is selected, then first 7 bits 1 to 7 we are sending through this, and last 2 bits 8 and 9, from this 8 and 9 bit we are sending to this. So this AD9, it is a combination of 1 to 7 and 8 and 9 when we are selecting ROM. If we are selecting RAM, it is AD7 only, so 1 to 7 bits they are sent to RAM for specifying the address. Now coming to 1 to 7 is over, 8, 9 bits are there. So 8, 9 bits, suppose ROM is selected, then as it is we are taking 8, 9 bits as an extension for the address. Now suppose we are selecting RAM. So if RAM is selected, one of the RAMs are to be selected, not all 4. So in 4 RAMs only one we are going to select. On what basis we will go to select? Suppose the value is 0, 0, then we are going to select 1. That is why here if it is 0, this is selected. If it is 1, second one is selected. So 1 in the sense 0, 1. So here one thing you can observe that 2 values we are having 8 and 9. For 2 values a combination of 4 set we will have. 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 1. These 4 values they will decide through decoder. Decoder will decide basing on these values which RAM is going to be selected. So if it is 0, 0, the value is 0, so RAM 1 is selected. If it is 0, 1, value is 1, so RAM 2 is selected. If it is 1, 0, value is 2, so RAM 3 is selected, and if it is 1, 1, value is 3, so RAM 4 is selected. That is 8, 9, these two, basing on the value of these 2 bits, we are going to decide which RAM is going to be selected. Apart from this, if it is ROM, then automatically the values of 8, 9 they are sent for an extension of address, because here we are having only 7, but here we require 9 bits for the address. So the extension 2 bits we are sending through 8 and 9. Now coming to 10. 10 bit, the value of 10, it will decide whether we are going to select RAM or ROM. If 10 bit value is 0, we are going to select RAM. If 10 value is 1, we are going to select ROM. So here once again we will discuss all the things. First thing, data bus. Data bus is connected to all the RAMs and ROM, but RAM, if it is connected, it is in a two-way connection. Both the ways it can send the data and receive the data also. ROM, if it is connected, it is one way only. Only we can read from ROM, we cannot write because it is read-only memory. Then we are having read and write. So basing on which operation is set, we will perform the operation either reading or writing. Then we are having 1 to 7. 1 to 7 bits, they are meant for specifying the address. Then we are having 8 and 9. 8 and 9 bits are used for selection of RAM. So which RAM we want to select, basing on the values of 8 and 9 we are going to decide. Basing on that 8 and 9, we are sending that to decoder. In the decoder, as an output we are getting 4 values, 0, 1, 2, 3. Basing on that values, which value is there, basing on that we are selecting that particular RAM. And 10th bit we are maintaining to set whether we want to select RAM or we want to select ROM. Now coming to auxiliary memory, here we are having various types of auxiliary memories. So once again I am repeating, auxiliary memory, it is the secondary memory. It is non-volatile. We can permanently store. It is very large data. it is cheap in size, we can extend the memory also whatever we are having. So, the hard disk whatever we are having, everything we will have in the secondary memory, permanently it is stored. But the disadvantage is that processor cannot directly interact with the secondary memory. So, though we are having permanently stored in the secondary memory, when the processor wants to utilize, first it is to be transferred to main memory, and then from main memory only the processor can interact. So, here various types of secondary memories we are having. For example, magnetic tape, simple understanding you can take. If you remember the tape recorder, the cassettes, whatever you are having in the tape recorder, the same way the magnetic tapes, the strips used to be there, on that they used to large data mainly for the purpose of backup, when you want to take the backup. So, usually big organizations weekly or monthly or frequently they will be taking the backups such that we are not losing the data. So, for that purpose we used magnetic tapes. Then came magnetic disk, hard disk drive, floppy disk drive and all these things, they comes under magnetic disk. Then optical disks we are having, CDs, DVDs, even now whatever we are using, that all comes under optical disk. So, the technology how we are storing and how we are accessing, that will differ here. Then flash memory we are having, the memory cards what we are using, the pen drives, very easy access, easy to store and all these as it together it will come under auxiliary memory, which is also known as secondary memory. So, now advantages of auxiliary memory if you are taking, it is non-volatile as I told you. Once if you are storing, it is permanently stored. So, once again whenever you want, wherever you want, you can open that and you can access the data. Reusable, again and again you can use, it is not necessary that then and there only you have to use. Once if you are saving with a file name, whenever you want you can go to that file name, with the file name you can search and you can access the data. Reliable, so the data in the secondary storage, once if you are storing, it is reliable, it will not be changed, the exact data only you can get again. And convenience, so it is very convenient for us because all the times continuously we cannot work. So, some work we have done, we want to save that, and again after some time again if you want to continue, we can go easily, we can access and work. And not only that, if you want to share the data, some other persons they will come and work on the same data. So, whatever it is very convenient to store the data on the auxiliary memory. And the capacity wise, if you are taking very large volumes of data, it can be stored in the secondary storage. And cost, if you are taking comparatively, the cost which is required to maintain secondary storage, it is very much less. That is the reason that extended data, we can extend the data also. That means whatever the memory we are having, that we can extend, and hard disk also, external hard disks we can maintain, and whatever we want we can maintain. So, all these are the advantages of auxiliary memory. Coming to magnetic disk, the structure of the magnetic disk if you are taking, it is first divided into tracks, then sectors, these all rounds whatever you are having, these are the tracks. Then it is divided into sectors. We are having read write head will be moving, and basing on the address or the location, we will move to that location and it can be read from there. So, various algorithms we are having, how easily we can reach from where we have to read. But the main difference between magnetic tapes and magnetic disks if you are taking, in magnetic tapes only from the starting we have to write. So, either we can fast forward or we can go back, but again from the starting only we have to start the searching. Whereas here directly if we know the position, if we know the location from where we want to read, the head point directly it can be taken to that particular position. Basing on the location, it will be specified in terms of which track, which sector, where it is located. So, various algorithms we are having, how easily we can move. maybe from the starting or from the nearest point, where how we are moving from one point to another point, how easily we can access and all. So magnetic disks, they are very comfortable and convenient for the users to store the data as well as access the data. So that's all. Again we will continue with associative memory in the next class. Thank you.